What is going on, guys? Welcome back. In this video today we're going to learn how to easily do retrieval augmented generation in Python using Postgres and PostgresML. So let us get right into it. Alright, so we're going to learn how to easily do RAG, how to easily do retrieval augmented generation in Python today using Postgres and PostgresML. Now, PostgresML are sponsoring this video today, so you can check them out at the link in the description down below. And the goal of this video is to implement and guide you through a basic example to show you a basic mini project of how we can use our own custom information, our own custom knowledge base in combination with some LLM like GPT, for example. So we can combine the intelligence of GPT, GPT-4, with our own knowledge base, with custom documents, with scraped data, with text files, PDF files, whatever, with content in a database, and then the large language model can use that knowledge in addition to all the intelligence it has already from the training data that it's trained on. That's the basic idea, and we're going to see how to do that using PostgresML in this video today. So the first thing we want to do is we want to go to the PostgresML website, to the documentation. As I said, you will find a link in the description down below, and you want to go to your operating system for the installation instructions. Now, for this video, I'm not going to show you the process of installing Postgres itself. I'm going to only guide you through the PostgresML installation because I will expect you to have PostgresML already on your system or to figure out a way to install it yourself, because that's not part of this tutorial today. Also, the installation is not that difficult. So basically what you want to do is you want to scroll down to your operating system. In my case, this is an Ubuntu-based distribution, and I have to basically just copy this. So you copy this code here, you run it in the terminal. This adds the repository to your system. Then you run this code to install the actual PostgresML package. And then you can also run this part here to clone PG vector and to install it on your system as well. So basically that's it for Ubuntu-based distributions. You copy this, you run it, you copy this, you run it, and you copy this, you run it. And then you're basically done on the operating side of things, operating system side of things. And what we need to do next is we need to set up a database that we want to use. And in addition to that database, we also need to then install extensions in that database, the PGML, so the PostgresML extension, the PG vector extension, and then we also need to install a Python package that connects to the database. So this is what we're going to do in this video today. That's the basic roadmap. So the first step is to open up a terminal and to use Postgres to create a new database. So we're going to call this database. We're going to use the create db command. And we're going to call this database PG tutorial. Let's call it just PG tutorial. And then we're going to go to a specific file. I'm going to use sudo privileges here. So sudo nvim to edit the following file in etc postgres, then 14, then main, and then pg_hba_conf. We need to add the line that allows us to actually connect to this. So we're going to say that we want to allow for the Postgres, or what was it, PGML tutorial. Did I call it PG tutorial or PGML tutorial? I'm not sure now. But basically to add this line here, actually I called it PG tutorial. So actually let's create another database, create db PGML tutorial. And now we're going to say service Postgres restart. I'm going to enter my credentials here and restart the Postgres database. Once this is done, we can connect to that database using the psql command. So we can say connect to the host, and now you have to provide your private IP address. In my case, this is 192.168.0.164. This is basically what you get when you type an ifconfig into your terminal or on Windows ipconfig. But that is just the host. This is just my private IP address here. I'm going to connect with the username Postgres. I'm going to connect using a password, and I'm going to connect to the DB with the name PGML tutorial. And the password is Postgres, and then I'm in the database. All I have to do here now is I have to run two commands: create extension vector and create extension PGML. Once this is done, I can get out of this database and we can move on with the Python code. Now, in my case, I'm going to use a Jupyter Notebook environment here, so Jupyter Lab. You can also use just a basic Python file, but what we're going to do first is we're going to install a couple of packages. I'm going to do this in the notebook. You can also do that in a terminal using pip or pip3. We're going to install the following packages. First of all, PGML. Then we're going to also install the OpenAI package because we're going to use OpenAI for the GPT access, which is also important. Let me show you that. If you don't have an OpenAI API key, it makes sense to go to the OpenAI page, to go to the API, to go to your platform, to navigate to the API keys, and to create an API key that you can use here. Either you have free credits or you can use a couple of cents to play around with this if you want to. But I have my API key here stored in a file. And the third package that we're going to install is the Wikipedia API package, just so we can get some Wikipedia information here. And I'm going to flag this, or I'm going to provide the upgrade flag so that we can make sure all of this is, actually pip install. All of this is up to date. In my case, it is. And then we can start with the imports. We're going to start by saying from OpenAI import OpenAI. I'm going to then also say from PGML, we want to import two things, the collection and the pipeline. The collection is basically a collection of documents, and the documents are just text. And then we also want to say that we want to import just the Wikipedia API. All right, so what we want to do now is we want to create a collection of documents, and we want to create a pipeline for splitting content and for searching for content. So we're going to say collection is going to be a collection, and this collection will have the name tutorial collection. And it's going to be linked. Actually, I need to do that before this. We need to define two things. First of all, the URL to the database, so the PGML database URL. This is going to be equal to the following connection string, Postgres, // and then we're going to use Postgres as the username, Postgres is the password, and we're going to connect to 192.168.0.164, my private IP address. In your case, it's going to be a different one, probably port 5432. The basic Postgres port, I think, and then it's going to be PGML tutorial, the database. And the OpenAI API key will be equal to opening the API key file and reading the content. So these are the two things that we need, the connection string and the API key for ChatGPT, or for GPT in general. Here now for the collection, we're going to pass the URL of the database. So we're going to pass PGML database URL. And then we're going to define our pipeline. Our pipeline is going to be a pipeline object, and it's going to be called tutorial pipeline. And now we're going to have to add a dictionary here. And this dictionary will contain a field text, or a key value paired text, which points to or a key text that points to a value, which is a dictionary, which then contains two fields called splitter, which is again pointing to a dictionary, and also a field semantic search, which is pointing to a dictionary. And here now we're going to define the model for splitting is going to be recursive character. We're going to also pass some parameters. These parameters are going to be, again, a dictionary. We want to pass a chunk size. So what is the size of one chunk of splitting the content? 1500 is what we're going to go here with here. And then we're going to also have a chunk overlap. And a chunk overlap will be 40. Now for the semantic search, we're going to use a Hugging Face model, which is from infloat. We're going to use the E5 small model. This is the model that we use to search the data that is part of our collection. So I'm going to close this now, and then what we're going to do is we're going to say await, and we're going to say collection add pipeline. We're going to add our pipeline to the collection. So once this is done, we can now add content to our collection. So once we have the pipeline, we can add content to our collection, and this can be done, for example, with the Wikipedia API. I'm going to show you the example, and then I'm also going to provide some custom data. What we can do, for example, if you want to add certain Wikipedia pages as part of your knowledge base, you can say, let's call this Wiki API is going to be equal to Wikipedia API.wikipedia. We're going to say here tutorial, and it's going to be in English language. And what we're going to do is we're going to get the page text for the Postgres Wikipedia entry. So we're going to say wiki API dot page Postgres like this dot text, and this gets us basically the text of the respective Wikipedia entry. Now, if we want to add this as an entity, as a document in our collection, we can do that by saying the following. We can say document is going to be equal to a dictionary. We have to provide a unique ID. Let's call this one here Postgres wiki page, and the text is going to be page text. And to add this document now, we just have to do await collection absurd document. Actually, documents. We need to pass a collection. I'm going to pass a collection with one element to the document, and then we can run this, and now it's part of our knowledge base. Now, what we can also do is we can define our custom text. So for example, I can say custom text is going to be equal to a multi-line string here, and I can say something, let's say something imaginary now, the price list of the ABC store at Pythonia, interpreted street 10, for example. And then I can say a coffee mug is $15. Then I can say a shirt is $40, and I can say a keyboard is $70, or actually let's go with $120, and then a mouse is going to be, I don't know, $80, like this. And this is now information that is not part of the internet. Obviously, I made it up right now, but this store now has certain prices, and the model knows about these prices if it looks them up in the database. So I can go ahead. Actually, this is not a plus. This is an equal sign. I can copy this, and I can do the same thing that I did with the Wikipedia page. I can do ABC prices, for example, and now I can add custom text, and I can add this document as well. Now I can copy these two cells, can paste them, and I can do the same thing now with another custom text. I can call it the XYZ store, which is at interpreted street 12, and it has different prices. Let's say the coffee mug is 50, the shirt is 90, the keyboard is 220, and the mouse is, let's say this one is cheaper, let's say 30. And then I can say that this now has the ID XYZ prices. All right, so I added a couple of documents to our database, and now we can use GPT to answer certain prompts. Now, before we use GPT, I can show you what happens when we ask for certain queries. So based on the query, the most useful, the most likely to be useful information is gathered from the database. So we can have something like a query text where, let's say our question is, what is Postgres, for example. This information will obviously be part of the Wikipedia page. So what we can do is we can do something like results equals await collection vector search. So we perform a vector search on our database, and we have the following query. So we have a field query, which is pointing to a dictionary, and this has some fields, which again, dictionary, the structure is a little bit unusual here. So we have a text, and then we have again a dictionary, and this is the query, and the query is pointing to the query text. Now, what we can also provide here is a limit. Let's say we're interested in a maximum of 3 chunks or 3 pieces of information here. We can do it like this. And then we can also add, or we also have to add the pipeline in the end. So this will get me results. And I can look at these results like this, or I can iterate over them, which is what I'm going to do here now. So I'm going to say for r in results, what I want to do is I want to actually print the chunk. And I want to say that I want to have 3 line breaks so that I can better read this. And then you can see I have 3 different chunks here that are interesting to my query. Now, this is not using any large language model yet. This is just looking up in the database based on the query, what is Postgres. It looks up the pieces of information that are most likely to give me the information I'm looking for. If I ask, for example, now a different query, how much are coffee mugs in Pythonia, I will get different results. I will get the price list of the XYZ store, the price list of the ABC store, and then some Postgres stuff because I only have 2 documents related to coffee mugs. So you can see that depending on my query, I will get different information. And now we can combine that with a ChatGPT or with a GPT query. So I can copy this again here. And then I can say that I want to initialize a client. The client is going to be an OpenAI object. So OpenAI, the API key is going to be equal to the OpenAI API key that I read from the file. Then we're going to provide some context. The context is going to be providing the information that we get from our results. So we are going to join the information here. So the chunks of information here that we get from the results for r in results. This is our context. We pass this context to the neural or to the large language model so that it actually, I need to save this so that it can actually look it up. And then we just use the basic chat completion here. So we can say chat completion is equal to client chat completions create. And then we're going to provide a message history. So messages is going to be equal to a list of stuff that happened. So we're going to say that, first of all, there is the following thing. The role is, oh, now I ran this. We need to provide a system prompt. So the role here is going to be system. And the content of the message is just going to be a simple instruction. You are a helpful chatbot. Given the following context, answer the user's question. Question to the best of your abilities. And then we can say stay brief, context, and then we can pass the context. And maybe we should use 2 line breaks before that. And we, of course, need to make this an F string. Otherwise, it's not going to work here with the context in the end. But that is basically our system prompt, providing the context. And then we can ask the question as a user. So we can then say we have now a second message here, which is going to be our user. So we're going to say role user is asking now the following question. So we have the following content here. Query text. So you can see why this already works. Basically, I'm using the vector search to find information that's necessary or that's helpful for my query. Then I pass it to the OpenAI GPT model to see that as information. So it's basically me putting it there, and then it can answer based on that information. And here we're going to say that the model we want to use is just a simple GPT. Actually, let's use double quotations, GPT 3.5 turbo. And then we can print our chat completion. So to actually get the message itself, we need to say chat completion choices 0, and then what was the correct way to address this? It was .message.content. And in this case, coffee mugs are $50 at the XYZ store in Pythonia and $15 at the ABC store in Pythonia. Then maybe we can also say, what's the only, or can I get anything cheaper at XYZ than at ABC? And then I will get an answer. Yes, you can get the mouse cheaper at XYZ store, $30 compared to ABC store $80. Now, of course, I made this list up, but you can imagine what you can do with this. You can feed in PDF files as long as you can get the text out of them. You can take any source of information and add it to your database. And now your GPT model is not just using its own intelligence, it uses all the data that you provided with. So you can literally build your own knowledge base and then pass it as context to your prompts. And this is how easily you can do that with Postgres, PostgresML, and OpenAI. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, don't forget to check out PostgresML at the link in the description down below. And besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.